Today, let's focus on graphing sinusoidal functions. Let's first graph the parent function y equals sine x. We know sine 0 equals 0, sine 90 degrees equals 1, sine 180 equals 0, sine 270 equals -1, sine 360 degrees equals 0. These are the key points of sine x. Let's write them down. So 0 degree, 0. 90 degree, 1, 180 degree, 0, 270 degree, -1, 360 degree, 0. To graph sine x, we can simply connect these key points using smooth curve. So something like that. There is the graph of y equals sine x in one period. Now let's see how to graph sinusoidal functions based on sine x. Say y equals 3 sine n bracket 2 x minus 90 degree bracket plus 4. The key step is to transform the key points of sine x to the key points of the target function. Because the amplitude a equals 3 greater than 1, so we need a vertical stretch by a factor of 3. That means we need to multiply the y coordinate by 3. So 3 times 0, 3 times 1, 3 times 0, 3 times -1, 3 times 0. The frequency k equals 2 greater than 1. So we need a horizontal compression by a factor of half. That means we need to multiply the x coordinate by half. So 0 times half. 90 times half. 180 degree times half. 270 times half. 360 times half. Now let's look at the phase shift. 90 degree greater than 0. So we need a horizontal shift to the right 90 degree. That means we need to add 90 degrees to the x coordinate. So get plus 90, plus 90 degree, plus 90 degree, plus 90 degree. Finally, look at the vertical shift. 4 units up. So that means we need to add 4 to the y coordinate. Now let's simplify these coordinate expressions. So the first one, 90 degree, 4. The second one, 135, 7. Next one, 180, 4. 225, 1. 270 degree and then 4. These are the key points for the target function. Let's plot them. So 90 and 4. 135 and 7. 180 and 4. 225 and 1. 270 and 4. Then we use smooth curve to connect them like that. So there's the graph of the target function. Now let's see how to graph sinusoidal functions based on cosine. This time we use a radian. First, let's graph y equals cosine x. We know cosine 0 equals 1. Cosine half pi 0. Cosine pi -1. Cosine 3 pi over 2 0. Cosine 2 pi equals 1. These are the key points of cosine. So 0, 1, half pi 0, pi -1, 3 pi over 2 0, finally 2 pi 1. To graph cosine, we can simply connect them using smooth curve again. So it would look like this one. So that's y equals cosine x. Let's see how to graph sinusoidal functions based on cosine. Say y equals -2 cosine bracket 2x plus half pi plus 3. Again, let's see how to transform the key points of cosine to the key points of the target function. Because a equals -2, so we multiply -2 to all y coordinates, so it would be -2 times 1. Next one would be -2 times 0. The next one, -2 times -1. -2 times 0. The last one, -2 times 1. Now k equals 2. So we divide x coordinate by 2 or multiply x coordinate by half. So we get 0 times half, pi over 2 times half, pi times half, 3 pi over 2 times half, 2 pi times half. Now d, the phase shift, should be -pi over 2. When we change that to standard form, x minus -pi over 2, we know d equals -pi over 2, and c equals 3. So we need to add -half pi to x coordinate, or minus half pi, minus half pi, minus half pi, half pi, the last one, minus pi. Finally, we need to add 3 to the y coordinate. So plus 3, plus 3, plus 3, plus 3, plus 3. Then let's simplify them. So the first one equals -pi over 2 and 1. The next one, -1/4 and then 3. The next one is 0. and 5. The next one is pi over 4 and then 3. The last point, pi over 2 and 1. These are the key points of the target function. So let's plot them. So negative pi over 2, 1. Negative quarter of pi and 3. 0 and 5. A quarter of pi and 3. Finally, half pi and 1. Then we use smooth curve to connect them. Like that. That is the graph of target function in one page.